India's mechanized infantry still depends on the BMP-2 Sarath, a vehicle family rooted in the 1980s. It can swim, carry troops, and fight alongside armor, but the battlefield around it has changed. Thermal sights, top attack missiles, drones, digital command networks, and heavier mine threats now shape whether infantry can reach the fight and survive it. The Futuristic Infantry Combat Vehicle program is India's long effort to replace that baseline with a vehicle designed for the next several decades. Armored personnel carrier mainly moves soldiers under protection. A tank is built around direct fire and breakthrough. An infantry fighting vehicle sits between them. It carries a dismounted section, but it must also observe, communicate, and fight while keeping pace with armored formations. That mixed job creates tension. More armor adds weight. A larger weapon takes internal volume. More electronics draw power and generate heat. FICV is therefore not one new gun on one new hull. It is a tightly coupled combat system. The BMP-2 became the reference point because it combined mobility, a compact tracked chassis, amphibious ability, and an autocannon in a package India could manufacture as Sarath. Modernization can extend that fleet with sights, fire control, and missiles. But upgrades eventually meet physical limits: available electrical power, internal space, payload, protection growth, and the fatigue life of an old architecture. A clean-sheet successor can reserve capacity for new sensors, countermeasures, and future variants from the beginning. The replacement story has taken several forms. An earlier acceptance of necessity dates to 2009. A make category route followed, but the program did not reach prototype selection. In 2019, the government said development agencies could not be shortlisted because the financial and technical criteria were considered subjective. A new request for information appeared in 2021. A fresh approval in principle followed in 2022. Then, in April 2026, DRDO publicly rolled out the Vikram VT21 advanced armored platforms. Defense programs can stall long before a prototype breaks down. They can stall while deciding who is qualified to build one. The official 2019 answer was unusually direct. Development agencies could not be shortlisted because the selection criteria were found subjective. That matters because a make project asks government and industry to share development risk over many years. If evaluation rules are not clear enough to survive scrutiny, investment cannot begin with confidence. The first lesson of FICV was procedural before it was mechanical. The June 2021 request for information reset the requirement around approximately 1,750 tracked vehicles. It asked Indian vendors to describe how they could begin supplying within 2 years of a contract, at a rate of at least 75 to 100 vehicles a year. An RFI is not an order. It helps the Army refine staff requirements, choose a procurement category, and identify credible suppliers. But it reveals scale. This is not a boutique fleet. It is an industrial program. The proposed fleet split shows how the Army expects the platform to work. Roughly 55% would be gun vehicles, the fighting core of the formation. 20% would be command vehicles. Another 25% would combine command and surveillance functions. A common platform can reduce training, spares, and maintenance burden across those roles, but commonality has to be engineered. Antennas, workstations, extra power, ammunition, and troop space all compete inside the same protected volume. India's geography turns mobility into a systems test. The requirement spans plains, semi-desert, desert, and high-altitude mountainous terrain. It also asks for river and stream crossing and operation in a chemical, biological, radiological, and nuclear environment. Wide tracks help control ground pressure. Power-to-weight ratio matters on gradients and at altitude, where engines lose output. Amphibious hardware adds mass and sealing demands. A vehicle optimized for one theater can become a compromise in another, so the design must carry margin. Protection is no longer just a thicker metal box. The first layer is awareness. Detect the threat before it fires. The next layer is avoidance or defeat through smoke, maneuver, and countermeasures. Then come modular ballistic and blast packages. Finally, the crew compartment, fire suppression, and the ability to move after damage determine whether soldiers survive the hit. DRDO says the VT21 platforms use modular blast and ballistic protection at stated SDANAG levels 4 and 5. But operational protection is proven through configuration-specific trials. DRDO's published VT21 configuration centers on an indigenously designed 30mm crewless turret. The described weapon stack includes a 30mm main gun, a 7.62mm PKT machine gun, twin anti-tank guided missile launchers, and a remote weapon station with a 12.7mm gun. Moving the crew below the turret ring can reduce exposed volume, but it makes cameras, displays, stabilization, ammunition handling, and electronic reliability central to fighting the vehicle. A modern fighting vehicle must shorten the time between seeing and acting. Commander, gunner, driver, and dismounted infantry need a shared picture. That picture may also draw from other vehicles, surveillance assets, and command networks. The hard part is not placing more screens inside the hull. Sensors must be fused, data links secured, interfaces usable under stress, and the system resilient when antennas are jammed or damaged. Digital architecture also determines how easily new radios, sights, and counter-drone tools can be added later. Ridges are predictable choke points. An amphibious vehicle gives a commander another way across water obstacles, but the capability is never free. The hull must remain buoyant and stable. Openings need sealing. Water propulsion competes with armor and payload for mass. DRDO says VT21 uses hydrojets for improved crossing capability. Whether that balance survives full combat load, rough water, and repeated service is exactly the kind of question trials must answer. On 22 December 2022, the Defense Acquisition Council approved acceptance of necessity for proposals that included futuristic infantry combat vehicles. Acceptance of necessity is an in-principle administrative approval to pursue an acquisition. It is a meaningful gate because it validates the requirement and allows procurement work to move forward. But it does not select a winner, freeze a production design, or place vehicles in battalions. Confusing approval with induction compresses years of engineering, commercial evaluation, trials, and manufacturing into one headline. FICV also tests India's defense industrial model. DRDO's Vehicle Research and Development Establishment designed the advanced armored platforms. Its June 2026 newsletter identifies Tata Advanced Systems and Burrit Forge as manufacturing partners, supported by many smaller firms. Armored Vehicles Nigam Limited separately lists FICV among its research and development projects. These paths show domestic capacity spreading across public laboratories, state-owned production, and private industry. The eventual procurement still has to convert that capacity into a transparent, supportable competition. On 25 April 2026, DRDO flagged off the Vikram VT21 advanced armored platform in tracked and wheeled forms at VRDE in Ahilyaanagar. DRDO says the platforms are intended for infantry combat vehicle and armored personnel carrier roles, with a high-power engine, automatic transmission, modular protection, amphibious mobility, and the new crewless turret. The rollout is an important hardware milestone. It demonstrates a real platform family and an industry team. It should still be described as a candidate capability, not an announced Army induction. 3 milestones must remain separate. A requirement explains what the Army wants. A prototype shows what engineers and factories can build. Induction means a configuration has passed the required evaluation, won a contract, entered serial production, and reached units with training and support. As of the research cutoff for this film, public official sources document the requirement, the 2022 approval, and the VT21 rollout. They do not, in the sources reviewed here, announce a final FICV winner or operational induction. A credible vehicle must now become a credible fleet. Mobility trials have to cover terrain, altitude, heat, dust, and water. Fire control trials must connect sensors, stabilization, and weapons. Protection has to be tested in the offered configuration. Reliability growth must expose weak components before serial production. Then the design needs spares, simulators, manuals, recovery systems, ammunition integration, and a supply chain capable of producing dozens of consistent vehicles every year. The program succeeds only when performance can be repeated at scale. FICV began as a replacement problem and became a test of process, engineering, and industrial depth. The need is clear. Move infantry across India's terrain, let them fight as part of a network, and protect them against threats the BMP-2 was never designed to face. The 2021 requirement established scale. The 2022 approval reopened the path. The 2026 VT21 rollout put new hardware in public view. The real finish line is later. A selected design, past trials, stable production, and vehicles that remain ready for decades.